Good morning again, grade 9. Let's
Good
have
morning, sir.
our new topic, which is volcanoes. Let me share my screen. Okay, can you see my shared screen now?
Yes, sir.
Volcanoes. Volcanism is one of the primary geologic forces that continually alters the Earth's surface. It is described as the movement of molten rocks beneath the Earth that is responsible for volcanoes. It produces changes caused by forces arising from within the Earth's crust. By the way, When when you hear the word geologic forces, what comes into your mind? Geologic forces. Margie and MD?
Movements of the earth.
Yeah,
Yes,
something with Earth because it's
something with
geologic.
correct. That's great. You see, geologic, it is actually movement of Earth's crust or movements of Earth's components. Geologic. Okay. It is described as movement of molten rocks beneath the Earth. Correct. Because as what I had told you in our previous lessons, that there are some forces or pressure beneath the earth. Okay? Magma associated with an explosive eruption may be 5 times more viscous than magma that is extruded in the quiescent manner. Viscous. What is viscous, by the way? Viscosity.
What, sir?
Viscous. Viscosity.
What? Where is that, sir? Viscosity.
Viscous. What do you mean by viscous? When you hear the word viscous, viscous. Okay, when you say viscous, it is lapot. Lapot ba? That's viscosity. Okay? Because these molten rocks actually in a viscous manner, tendency is the movement is slower. Okay? But this is associated with explosive eruption. When say explosive eruption, this is one of the dangerous eruption in a volcanism. Okay? Let's tackle later the volcanic eruption. A volcano is an example of extrusive volcanism. Extrusive. Extrusive means outside. Okay? Intrusive means inside. Extrusive meaning to say that you can actually observe it that the it is actually outside. You can see it outside. When volcanic activity takes place above the ground, so that the hot molten magma released into the landscape, we say that the volcanic activity is extrusive. It's outside, meaning it is in the exterior or outside the crust. Okay? Extrusive volcanism is a phenomenon that takes place when the magma under great pressure with molten materials forces its way through the fissure of the underground rocks and reaches the Earth's surface to form igneous extrusion or igneous rocks. Extruded materials include the molten rocks or molten materials that reach the surface of the volcano. This volcanic activity is also known as surface volcanicity. Okay, again, when say extrusive, it's outside. The phenomenon takes place when the magma undergoes great pressure or multi-material forces through the fissure. Fissure is a crack, okay, underground that reaches the Earth's surface. When a magma reaches the Earth's surface, it will now called as lava. Again, when the magma reaches the Earth's surface, it will now called as magma or lava. Lava flows. Intrusive, on the other hand, volcanism is when the magma is forced into rocks okay, that make up the Earth's crust. It occurs there in the lines of thickness such as fault joints or bedding planes in the crust. Okay, then the magma enters these lines of weakness when it cools and becomes solid while still underground. The different features like plutons, dikes, seals, lacoliths, batholiths may be formed. The rock formed is intrusive igneous rock. Okay, again, when we say intrusive, the volcanic activity there is beneath the Earth's surface. So it was not actually released in the Earth's surface, so underground. So making your dikes, plutons, seals, lacoliths, and batholiths. Okay, these are underneath the Earth's surface. Question so far with intrusive and extrusive, MD and Margie? Question so
No,
far?
sir.
Okay. Most magma is generated by a partial, but let's move now to volcanic eruption. Most magma is generated by partial melting in the upper mantle to form molten materials. Okay. Having basaltic, andesitic, or rhyolitic composition. Again, this magma could be basaltic or basalt, andesitic, or rhyolitic composition. Once formed, the buoyant molten rock will rise toward the surface because the density of the crustal rock decreases the closer they are to the surface. Ascending basaltic magma or rhyolitic magma reach the level where the rocks above are less dense. Should this occur, the molten material begins to collector pond, forming a magma chamber. Okay, this is now how your magma chamber is being formed. As the magma body cools, minerals having high melting temperatures crystallize first, leaving the remaining melt enriched in silica and other less dense components. Okay? Some of these molten materials may ascend to the surface to produce volcanic eruption. In most tectonic settings, only fraction of magma generated at deep ever reaches the surface because it will eventually cool down. Again, only few or only fraction of magma generated at the deep ever reaches the surface because it will generally cool down in the process of traveling. Hence, you can form your magma chamber. So again, if this is the structure of composite volcano or anatomy of volcano. As you can see your magma chamber. Okay, while traveling to the vent, okay, your magma cools down, making now your intrusive volcanism. Okay, intrusive explosion or intrusive volcanism, volcanic activity. So it is now making your magma chamber. At the same time, while traveling, some of these may cool down. Okay, adding component in your vent. This is your vent, crater, your crater and your vent, and some of these may actually travel in the side vents. Okay. Questions so far, Margie and MD?
No, sir.
Okay.
No, sir.
Let's move now to the classification of volcanoes. How can we classify volcanoes? Okay. We usually classify volcanoes as active, inactive, or dormant. Let's take a look, a closer understanding with these terminologies. Active volcanoes are those are currently in state of regular eruption. Okay, again, active volcanoes are those with currently in a state of regular eruption. That's your active volcano. It may be going off right now or had an event last few decades. Further, a volcano is classified as active volcano if the present time it's expected to erupt or is erupting already. So if it is erupting already, then it is considered as active volcano. So therefore, the presence of magma there is still moving, and then we are just classifying it as active volcano in order for us also to to be prepared when it comes to volcanic eruption. Or the people there will be prepared, the LGUs will prepare something um, for the people in order to be prepared. A dormant volcano, on the other hand, is one that is capable of erupting. Although it is dormant, considered as dormant, it is capable of erupting and will probably erupt again in the future. But it hasn't had an eruption for a very long time. Okay, it doesn't have an eruption um, in a very long time. Inactive does not necessarily indicate that the volcano will not erupt again. Okay, inactive, in the other hand, does not necessarily indicate that the volcano will not erupt again. This volcano is expected to have an eruption sometime in the future. Okay, let's have the summary. Active volcano. These are currently in state of eruption, and in the present time, it is expected to erupt. Dormant volcano, capable of eruption, and will probably erupt again in the future. Okay? Inactive volcano does not necessarily indicate that the volcano will not erupt. Okay? And expected to have an eruption sometime in the future. Sure. Why is that so? It is actually classified that way in order for us to identify the pressure points. Remember that these are exit points, and we are still considering the pressure underneath. It is not constant. To tell you honestly, this is not constant. And again, it depends upon the movement of plates. It depends upon the movement of magma underneath the Earth's surface. Let's move now to types of volcanoes. Are you still with me, Margie and MD?
Yes, sir.
Okay.
Yes, sir.
Let's move now to types of volcanoes. Let's take a look at shield volcanoes. Okay. They are produced by accumulation of fluid basaltic lava and exhibit the shape of a broad, slightly domed structure that resembles a warrior shield. That is why it is called shield volcano. If highly fluid lava extruded, the volcano takes a shape of a broad, slightly domed structure that resembles a warrior shield. Pyroclastic materials are clouds of ashes, fine dust, volcanic bombs, and blocks of lava fragments that are carried through the air and vapor. Okay, those are the materials being excluded. So this is the anatomy of a shield volcano. As you can see, it has a vent, magma chamber, and you look at the layers of lava. Okay, it is actually resembled as a dome shape. Cinder cones or cinder volcano. These cones are also called the scoria cones or soria cones, are built from ejected lava fragments that form a cinder or clinkers as they begin to harden in flight. In flight meaning during the volcanic eruption. Cinder cones or cinder volcanoes have a very simple, distinctive shape determined by the slope that loose pyroclastic materials and maintains as it comes to rest. If we're going to look at your cinder, it is really simple. That is the cinder volcano. Okay? It looks like Astoria, as you can see. It is why it is not domed. You look at the dome, it's really different. Okay, or shield volcano, it is really different compared to your cinder. Okay, your cinder is really simple, and if you're going to look at it, it has a lot of space in between. Let's move now to composite cones or composite volcanoes. Composite cones, also known as stratovolcanoes, make up some of the most pictures and known volcanoes that have on Earth. These composite volcanoes usually made up of several layers of hardened lava and volcanic ash from the explosions that already take place. This is normally why they can make such peaks because of constant overlapping that takes place. These volcanoes usually erupt violently and have the higher number of casualties than the other volcanoes because composite volcanoes has a an explosion that you know really destroys the area because it has a violent eruption just like your Mount Mayun. Okay, and again, materials being excluded there. We have volcanic ash. We have also um, lahar, or the mixture of mud. So these are the pictures. As you can observe, it is a violent eruption. Okay, but it forms a strato, no? Stratovolcano. This is usually pictures because the shape is really good. If you're going to look at it, it's really nice to look at. Other volcanic landforms, you have calderas. No? A caldera is a volcanic feature formed by a collapsed volcano into itself, making it a large special form of volcanic crater. Okay. It is also called as bathtub volcano. It looks like a bathtub. Caldera is, or caldera comes from the word caldaria, caldero. No? It is a cooking pot. Are large depression with a diameter that exceed 1 kilometer and have somewhat circular form. Okay? Calderas are formed by one of the following process. We have two processes. We have three processes. The collapse of the summit of a large composite volcano following an explosive eruption of silica-rich pumice and ash fragments. These are crater lake type caldera. This is the crater lake. The crater lake type caldera. It is actually filled with water simply because a long time it actually um, collects water in the surface. Crater lake. The collapse of top of a shield volcano caused by a subterranean drainage from the central magma chamber. This is the Hawaiian type caldera. Okay, Hawaiian type caldera. And the third one is the collapse of the large area caused by the discharge of colossal volumes of silica-rich pumice and ash along the ring fracture. This is now the ring fracture. Remember your ring fracture katong dito mo agi ang some of the lava. This is the Yellowstone type caldera.
Ah,
Yellow.
yes, sir.
Okay, this is now the Yellowstone. Other than caldera, you can also have the flood basalts. Okay, flood basalts or flood basalt is a result of a giant volcanic eruptions that coats large stretches of land and ocean floor with basalt lava. These eruptions do not produce very much ash. Instead, they produce a prodigious amount of greenhouse gases. Okay, since greenhouse gases, especially carbon dioxide, flood basalts have occurred on large igneous provinces in prehistory, creating a great plateaus. Okay, this is how your plateaus are actually created, and mountain ranges. These have erupted at random intervals throughout geologic history and are clear evidence that Earth undergoes periods of enhanced activity rather than being in a uniform steady state. Meaning to say that Earth is not actually in a steady state. Earth is not stagnant. It is still moving until now. Okay. This is your flood basalt. Okay. As you can see, there are some scattered lava or lava flows. This is active flood basalt. Okay, why do we need to study volcanoes? Okay, any idea? MD and Margie? Why do we need?
Because if we don't study, we cannot,
Yes, MD, go.
like, we cannot know, sir, ba?
Cannot know? Yes. Yes.
Yeah, parang if you know, you can easily go get help or shelter. Like you can prevent yourself from getting hurt.
Correct. The point is there. Any other idea, Margie?
What's the question again, sir?
Why do we need to study volcanoes?
We need to study volcanoes in order to be alarmed of when will they erupt anytime if you're living near them.
Yes, Margie,
And the
continue.
benefits that will affect the environment.
Correct. Okay, Margie, you have a point. This is for us to be prepared and for us also to get the benefit out of it. Yes, that's the point. Since we still have 10 minutes left, I'll stop my share screen. Let's continue the discussion by next meeting. And only MD actually performed the activity last time, the activity that I had given. I will give chance to Margie. I'll open again the activity one and do your activity. Okay, Margie,
Okay, sir.
right? I think that will be all for today, class. And by the way, by next meeting, we may not have our Zoom meeting. I'll just leave an activity in the LMS. Okay? Again, I'll just leave an activity in the LMS. I think that will be all for today, class. Thank you for your participation and have a nice day, everyone. Goodbye.
Thank you, sir. Bye.